Hello everybody, this is a presentation on the new pulsar, and the first video here is going to be on the features of the new pulsar, its packaging and what it basically can do. There'll be other videos demonstrating the functionality. So the first thing that you'll notice is that it's in a very compact box. Hopefully I'm letting the camera see all this. And on the left side we have an on-off switch, power cord, and a 10 amp fuse. The 10 amp fuse is to handle the current surge of some very large caps inside. The circuit board inside is actually fused for 4 amps. Alright, so let's do door number one. Door number one, let's do the other side first too. The other side has two wall outlet receptacles that will accept any AC driven resistive type load device. What that means is that it will accept heat blankets, heaters of all different types, as long as they don't exceed the current draw that the box is presently capable of producing, which right now it's set up for 4 amps at 400, that's roughly 400 watts worth of power. And we'll give some demonstration of real-world devices in the second video. Alright, here we go. Under door number one we have the frequency generator. This frequency generator is definitely an overkill for this box, but because of its price, its availability, and so forth, this is what we're going to use in here. What it is, it's a 0.01 hertz to 5 megahertz frequency generator, capable of 3 types of triangle waves: leading edge, trailing edge, and pyramidal sawtooth. And it also has or triangular wave. It also has sine wave capability and square wave capability. It's got a digital display. Again, I'll show you the digital display. And it's used to communicate the frequency, the duty cycle, what type of wave pattern you're actually running. And it's also an input device for saving memory, loading memory, and there's several other functions that this frequency generator has. Again, I'll go over more of the functionality in actual use in this second or third video. Right here is just a optical encoding knob that allows you to dial in the frequency, but you can do frequency jump selections with these buttons that my finger was pointing to, the red buttons. Alright, so this is the primary oscillator for the box, used to change any 60 cycle that you plug in from your wall outlet into some other usable frequency up to practically about 50 kilohertz. So it's a frequency converter. This box is a frequency converter. Even though the oscillator can go up to 5 megs, it can convert AC wall outlet electricity, which is typically 120 volts RMS, to 160 volt, which is the peak of the RMS, volts DC, and pulse it from 0.01 hertz all the way up to about 40 or 50 kilohertz, and give you a reasonably good representation of a square wave pulse. You get going higher than that, and what happens basically is you don't have a square wave pulse anymore. The duty cycle doesn't represent the pulse width properly. It just sort of fades out because it exceeds, those frequencies exceed the MOSFET switching power or switching speed that's used in this particular box. So, any of you geek types out there, if you want to recommend high-powered fast switching MOSFETs that I might consider using in this box, send me an email or drop me a line. Alright, so that's under door number 1. Under door number 2, we have a MP3 player and an outlet, and the MP3 player can replace the frequency generator. Using a program like Audacity, you can generate audio files, and they can be complex wave patterns, sequences of wave patterns, to drive the frequency conversion from, again, anything up to 40 kilohertz if you had a file capable of generating a 40 kilohertz signal. These little cheap MP3 players do not have that capability. They go up to about 20 kilohertz max, well within the range of the capability of this box. If you look at the Rife frequency list, there are several of them on the internet, or the Hulda Clark frequency list. This pretty much will cover all the frequencies that are defined in their books or papers or PDFs that you get a hold of. That was one of the intents of this frequency converter box, was to be able to do a reasonably good job at converting AC wall outlet electricity to pulse to DC, ranging from a hertz roughly up to 20 kilohertz. So you could do things like run an electric blanket. Instead of running it at 60 cycles, you could run it at Schulman's resonance of 7.83. Or you could run a far infrared heater. That's what this is. It's a far 150 watt, and we will demonstrate that later, 150 watt far infrared heater, and pulse it at some frequency that you have chosen to meet your particular needs. Or, this is my favorite, and I'll probably have to dedicate a whole video to this, and this is my vortex coil that we can generate magnetic pulses with, that will fill up this whole room that I'm doing this little presentation in. And very responsive, can generate pulses up to over 100 kilohertz with power, with quite a bit of power. So we'll give a presentation of this being run or working with the pulsar, as I call this, or the frequency converter box. Under door number 3 is the inside of the box, and I don't know how well you can see that. The blue caps are rather large. They're 33,000 microfarads worth of capacitance there, capable of storing up to 200 volts. They'll typically get charged up to 162, 63 volts. You want to keep your hands out of it. You do not want to touch those, because that's a lot of current capacity, capable of giving you a nasty burn. So with that, I'm going to move on to video 2 and do a little bit more show and tell by demonstrating the unit and its functionality, and give you some scope images and so forth. So catch you on video number 2.